Okay everyone, it's time for a new chapter. We're going to be looking at chapter 3, which is on rational numbers. And I guess the first thing we should probably do is talk about what are rational numbers. So that's going to be the focus of today, figuring out what they are and kind of working with them a little bit. So a rational number, as you probably know, you've probably done this before, a rational number is any number that can be written as a fraction. It doesn't mean it is written as a fraction, it means it can be written as a fraction. So let's start by looking at integers and discussing whether they're rational numbers. Do you know what integers are? When most people hear integers, they say that they're talking about negative numbers. And that's partially right, but it doesn't cover it all. Because, believe it or not, 4 is an integer. Yes, negative 4 is an integer, but so is 4. So some positive numbers are also integers. Like the counting numbers, 1, 2, 3, 4, 5, 6, 7, those are all integers. So 0, that's an integer. Here's another thing. If you think of integers as just being negative, you might think that 4.2 is an integer. It's not. The integers are all the counting numbers and all the negative counting numbers, plus 0. So here's the integers. Dot, 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 what's that mean? It means it goes on down forever, right? Negative 10, negative 9, negative 8, negative 7, even lower than that. Anyway, it comes on up to negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, goes on and on forever up in the positives, on and on forever down the negatives. But you'll see there's no decimals in here. 1.5 is not an integer. Negative 2.7 is not an integer. It's only those counting numbers, the whole numbers, and the negative whole numbers, or negative counting numbers. Alright, so what's the case about integers? Are they rational numbers? Can you write all these numbers as fractions? Yes, you can. These are rational numbers. How come? Let's just consider one of them. Let's consider the number 3. How could you write 3 as a fraction? Well, there's a couple things you could do. How about 3 over 1? That equals 3. How about 6 over 2? 6 over 2 is the same as 3. How about 300 over 100? I could write the number 3 in many, many different ways as a fraction. So it is a rational number. All the integers are rational numbers. Okay, how about fractions? Are they rational numbers? Okay, that's a ridiculous question. I just said rational numbers are any number that can be written as a fraction. So therefore, fractions must be rational numbers. Okay, any number that can be written in this form, a over b, is a fraction. Except the b here cannot be 0. Why? Because you can't divide by 0. I think I've probably told you that already. But this number here, b, cannot be 0. And both numbers, a and b, have to be integers. Okay, so every fraction is a rational number. Decimals. Are decimals rational numbers? Well, not all of them. Decimals are rational numbers if they repeat or they stop. Okay, the proper word for stopping is terminate in math. It's if they repeat or terminate, but I thought I'd just put stop. So if it's either one of those two things, then it is rational. So for example, 4.32, and I'm putting this little line over the 3 and the 2. What does that mean? That means 4.32323232, and how long does that go on for? Forever. And that repeats, the 3 and the 2 repeat, so it is rational. How about this? 4.32 and the line's just over the 2. That means 4.3 and then the repeating part, 2, 2, 2, 2, 2, 2. It's repeating, so it's rational. How about 4.32343791 and then it just stops? Yeah, that stops, that terminates. So that's a rational number. How about 3.2? Yeah, that stops, so that's a rational number too. Okay? So what would an irrational number look like as a decimal? An irrational number would look like something like 4.189213471123987. See, it's just a bunch of random numbers here, and it's not stopping. I'm going to do this for the rest of all time. Okay, I'll just fast forward the video a bit, but I'm going to do this the rest of time. 3218914. Wow, that was fun. I did it for the rest of all time, and it's an irrational number. Okay, so square roots. Are square roots rational numbers? Well, if it's the square root of a perfect square, then it is rational. So for example, if you were taking the square root of, what's a perfect square? How about 81? That's a perfect square. That's definitely rational because the square root of 81 is 9. A number that multiplies by itself to give 81 is 9. That's what we did last chapter. And that's definitely rational because that's an integer. It can be written as a fraction, 9 over 1, right? So that's definitely rational. But if you're looking for the square root of a non-perfect square, an imperfect square, then it's irrational. Irrational means not rational. So for example, what if we weren't doing the square root of 81? What if we were doing the square root of 80? The square root of 80 is 8.9442719099999. Oh, it must be repeating. No, it doesn't. 1, 5, 9, and it just keeps going on and on and on. Okay? Never terminates, never stops, and it never repeats, so that's definitely irrational. Alright, that's about what you need to know about rational numbers. So we're going to go through and we're going to decide whether these numbers are rational or irrational. Okay, the first one is negative 25. What do you say? Well, that is an integer, isn't it? It's one of the counting numbers, but negative. So this is rational. I'm going to put an R for rational. How about negative square root of 25? 25. Is that a perfect square? It certainly is. The square root of 25 is 5, so basically what we have here is negative 5, and that's another integer, so it's rational. How about negative square root of 5? Okay, this is not an integer. 5 is not a perfect square. If you were going to take the square root of 5, you'd get, I don't know, I'm not going to do it, but it's going to be like 2.31427. It's going to go on and on forever. This is irrational. No, irrational. I for irrational if you want. 0. Can you make a fraction out of 0? Sure. 0 over 1, 0 over 2, 0 over 3, 0 over 7, 0 over 28. Those are all fractions with 0, so R. Rational. 1/3. This fraction here. Is this fraction rational? Of course, it's a fraction, so it's rational. Cube root of 8. Now, I didn't talk about cube roots of 8 up here, but I bet we can figure this out. Is this a perfect cube? Is 8 a perfect cube? Is there a number that multiplies by itself 3 times to get 8? Sure is. That number is 2. 2 times 2 times 2 is 8. So 2 is definitely rational. How about the cube root of 9? Is there a number that multiplies by itself 3 times and gives you 9? There is not a whole number that does that. Don't say 3. 3 times 3 times 3 does not equal 9. It equals 27. This doesn't work. This is not a perfect cube, so it's irrational. 4.3 repeating. This means 4.333333333. And remember what we said with decimals, if they repeat or stop, then it's rational. So yes, this is a repeating decimal, it's rational. Now, this is one of these all-time ones. It goes on forever. 7.2123574, blah, 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 but just keeps going and going and going. Random numbers. It's not stopping. It's not repeating. This is irrational. Not rational there. Now this one, long decimal, 9.8345676, but it does stop right there. So it stopped. It terminated. It is rational. And the most famous of this type of number, pi, right? 3.141. I'm so bad. I'm a math teacher. I know it to like 3 spots. But you know that this thing goes on and on and on forever, and it never stops, and it never repeats. So it never does either of those two things. It must be irrational. It's the most famous irrational number of all. But I'm sorry, I got to cross you out because you're not rational. Okay, a few other things you probably need to know here. These two processes are going to help us compare some rational numbers. So the first thing that would be good to do is to switch a fraction into a decimal. Do you know how to do that? It's actually pretty straightforward. You're just going to divide. So for example, if it says 23 over 6, and you want to figure what that is as a decimal, what's this line right here mean? It basically means divide, and that's what you're going to do. You're going to go 23 divided by 6. So here we go, 23 divided by 6, and my answer shows up right here, 3.833333, and that actually repeats. Unfortunately, calculators aren't able to show us the repeating sign, but that is a decimal that goes on and on forever. So 3.83, and then that 3 there is repeating. 3.83333333, so this 3 repeats. Okay? Here's another one, 3 4/9, and we're going to put it into a decimal. Okay, well why don't we just put 3 point and then figure out what 4/9 is. How do we do that? Divide. 4 divided by 9. So here we go. 4 divided by 9. It is 0.444444444. So don't put 0.4444, remember. We already have the 3 there. So we need the 0.44444, don't we? So 4 repeating, and we're done. So that's how to switch to decimals. How do we switch from decimals to fractions? There's different ways to do it. What I like to do is to think of place value. You know what I mean by place value? So let's take a look at this first one. What place value is that 2 in right there? That's in the tenth, with an S at the end, right? Tenths. What's the 5? That's the hundredths. Hundredths. I know you probably can't read my writing. What's the 4? It's the thousandths. And what is the 7? This is the critical one because it's the last one. It's the 10 thousandths. So what we have here is 2,547 10 thousandths. And that's literally what the fraction is. 2,547 over 10,000. Because that's the place value it's in. Okay, let's try another one of those. Okay, first of all, we have this 4 here. What should I do with that? Well, why don't we just put a big 4? It's going to be a mixed fraction. Big 4. Now we think of our place value. It's really only the last one that matters. 2 is in the tenths, and the 6 is in the hundredths. So we have 4, and then there's 26 hundredths. That's it. But wait a minute. See what you could do to this fraction? You could put it in lowest terms. Keep the 4. You don't have to do anything with that. But with the actual fraction part, you could divide top and bottom by 2 and get 13 over 50. And that's an even better answer. Okay. We're going to find these numbers on the number line. -3. Well, that shouldn't be too bad. There's 0, -1, -2, here it is. -3 is right here. I don't know. I'll just write it right on top of it. 4. This is ridiculous. 1, 2, 3, 4. Here it is. Positives come up this way. Negatives go down that way, right? Okay, -1/4. We start at 0. We want to go in the negative direction. Is a quarter as much as 1? If you have a quarter of a pizza, do you have a whole pizza? One pizza? No, you don't. So you don't go all the way to here. A lot of people put their -1/4 there, but that's not true. That's -3/4. -1/4 means you've only gone 1/4 of the way towards -1, so it would be right there. Right around there would be -1/4. How about 0.33333333? Okay, well that 0.3 is not as much as 1. It has to be between 0 and 1 because it's positive, but it's less than 1. Halfway would be how much? 0.5, so this isn't quite halfway. In fact, 0.333, some of you probably know, is exactly a third. So it should be a third of the way is your 0.3 repeating. 2.5, that shouldn't be bad. 1, 2, and then we also go a half. So there's 2.5 right there. Alright, now we're going to put some signs in to make these statements true. Do you know these signs? This one means less than, and this one means greater than. You know the trick. The mouth goes towards the bigger one, right? The greedy crocodile eating the bigger number. So what's bigger, 3 or 3.2? Well, if you're at all confused, you could make a decimal here, this 3. It would be 3 point what if it's just 3? 3.0. So what's bigger, 3.0 or 3.2? Definitely 3.2. How about -4.6 or -4.7? A lot of people say 4.7 here, right? 7's bigger than 6. But remember, we're talking about negatives here. -1, 2, 3, -4, -4.1, 4.2, -4.3, -4.4, -4.5, -4.6, and then -4.7 comes after that. It's further to the left. A bigger negative, right? This is a bigger negative, so it's smaller. This always confuses people. But a bigger negative is actually smaller. So this is the bigger number. Okay, how about this one? Tough to compare right now, so why don't we just expand this a bit? 2.34 is the same as 3, 4, 3, 4, 3, 4, like that. I'm going to write this other number right below it. 2.3436. So if you compare it now, these numbers are the same, 2 and 2, 3 and 3, 4 and 4, 3 and 3, that's all the same. But now this one has a 6. Well, 6 is bigger than 4, so that's the bigger one. Which one was that? That was this one, so that's bigger. Okay, 2/7 and 0.35. Well, I got a couple choices. I would either change this into a decimal, or I would change this into a fraction. Change into a decimal is pretty fast if you have a calculator, so why don't we do that? It's just 2 divided by 7. 2 divided by 7 is 0.2857. So this one is 0.2857. What's bigger, 0.28 or 0.35? 35 is bigger. Okay, how about this? Well, you could switch them both to decimals. That's one way to do it. Or the other way you could do it, get common denominators. What's a common denominator of 5 and 9? 45. What do you multiply 5 by to get 45? 9. So also multiply the top by 9 and you get 36. What do you multiply 9 by to get 45? 5. So also multiply the top by 5 and you get 35. Oh, it's so close, but 36 is a little bit bigger. And the last one, I'd probably do dividing again. So this is negative 1.76 and this is negative 9 over 5. Back to the calculator, 9 divided by 5. 9 divided by 5, 1.8. So we have negative 1.8. If you want, you can add as many zeros as you want after, right? So I'll put another one. So this is negative 1.76 and this is negative 1.80. Be careful. 80 I know is bigger than 76, but bigger negatives are actually smaller. This is the bigger number. On our number line, if here's 0, negative 1, negative 2, negative 1.8 is further down the number line than negative 1.76. So this is bigger. Okay, find a decimal rational number that falls between these two fractions. So what I think you should do, would make probably the most sense, turn them both into decimals. So negative 21 over 23, that's 21 divided by 23. 21 divided by 23. Let's do it to 4 decimal places. 0.9130. 0.9130. And then for this one, it's also negative 23 divided by 25. 23 divided by 25. 0.92. 0.92. So this is negative 0.91. This is negative 0.92. This is a bigger negative, isn't it? This one's a bigger negative, which means it's smaller. So the bigger one is this one. And finally, find a fractional number between each pair of decimal numbers. I think what I'd do first is figure out a decimal that's between them and then turn it into a fraction. So this is negative 2.00 and then the 1 repeats. 1, 1, 1, 1, 1. And then this one, I'll write it right underneath, it's negative 2.001 and then it stops. But what could you add on to that? You could add a bunch of zeros, as many zeros as you want. Now, we could get rid of some of this. You probably don't need as much as I have here. Think if I take it to there, we can really understand this. We have 0.00 and then 111, and here we got 0.00 and then 100. So all you have to do is think of any number between 100 and 111 and put it in there. So how about negative 2.00 and then a number between 100 and 111? I don't know. How about 103? Sound okay to you? That'll work. Anything from 101 all the way up to 110 will work, and it'll be between here. Now we have to change it into a decimal. Okay, well let's not worry about this first part. That negative 2 will make our big number, negative 2. And what's left over here is 0, 0, don't have to worry about that, 103. 103 is our numerator, and we just have to think of place value. Whoa, we gotta go a long way. Tenths, hundredths, thousandths, 10,000ths, 100,000ths. 100,000th. There you go. Negative 2 and 103 over 100,000 is right between those two decimals. How awesome is that? Gotta love these rational numbers. Okay, we'll be working with them lots in this chapter. Take care and make sure you ask me lots of questions. Bye.